Okay, firstly, let's give some behavior to this goal. So it goes around and has also some up and down movement. So before we add that behavior to anything, let's just test it normally in a script. So let's create a folder called scripts and create a C# script called reacher goal and test. So this is just for movement test. And we are going to first add to this robot. So eventually we will have the robot to control all the movement. So we were going to add this to the goal. Yeah, to the robot. Yeah, and add the script to open the script. Okay, so let's delete these 2 lines, which we don't need. And let's bring the public game object and bring the goal. Control S. And now we see this goal. Let's bring this goal in. Okay. We are going to set up a few things. We are going to set a public variable, public float, and goal height. This is the first height of this geometry of this ball, and only public value will be that. So all the others will be a private value. Let's just set them. So m goal radius float and goal degree float and goal speed float and goal deviation float and goal deviation frequency. Okay, so what they do is this determines the radius of the goal area, goal zone, goal area zone, and goal degree. This is how much the goal rotates on each frame, and the speed, basically speed of the goal zone around the arm. Yeah, speed of the goal rotation. And the deviation, this controls the up and downs. So how much goes up and down from the goal height as a basic first height. And then the frequency of the goal up and down movement. So actually the speed is this rotation speed. Yeah, and the deviation frequency determines while this is rotating, how much like up and down how frequently you go up and down. So all of these will be set as some random random parameters. Okay, so for now, we are going to create a method to control all of that. And we are going to just make this public method, public void set and reset parameters. And we are going to set all of this. So we're going to say, okay, that is from random range, range from 1 meter to maybe 1.3 meter. Sounds good. And the degree will range from random range. So this should be range from 0 to 360, 0F to 360F. And the speed, let's copy Ctrl+C, Ctrl+V and change this number to -1 to 1 or maybe 2. Range the speed from -2 to 2, and the deviation should be -1 to 1. We don't want to have it too high or too low. So if your first goal height is 1.2, you don't want to range this too low compared to this one. If you set 1.2 minus 1.2, it goes to 0, goes to the ground. Yeah, so you don't want to have your goal go to the ground or like minus to the ground. Okay, so deviation frequency can range from 0 to 3.14, like a pi around. Okay, so these should be called in the start, and in the update we're going to call something called void update goal position. So this will be called here, but we are going to use these ones to update the goal position. So we are going to translate this degree to a radius. So let's say var m degree as a radians. So to do that, we could have just done that in the setup, but anyways, so we change this by using math pi divide by 180. Okay, so we're going to use this number. Okay, and var, and we have to set goal X and Y and Z. So goal X, let's just set it first. Yeah, so var goal Y, var goal Z. Of course, var, if you use var, you have to assign a value immediately. But we are going to do it very soon. So we are going to use these 3 values to create the new position. So goal X, goal Y, goal Z. Yeah, so we are going to make the up and downs values to Z. So yeah, it's up to you how you set this. Yeah, but let's set this one X and Z, because in Unity, Y determines the up and down. So we are going to set the variation X and Z first and use the Y to determine the up and down. Okay, so for this one, we are going to use the radius just to calculate the circling mathematics. So you are going to use the cosine and sine. We are going to use this radians of the degree to determine X and Y position. So X is cosine and C is sine, which is the two-dimensional position of the ball. And if we just want a simple height, obviously we can just use this one. But we want to have this up and down movement on top of it, right? So we are going to then do some mathematics. We can just simply add the goal deviation times mass times mass F cosine, use the deviation frequency times deviation degree as a radians. So this will determine the up and down movement, which is already assigned to this Y position, okay? So this one will be called in here. And finally, in the update, the goal degree, this goal degree should increase by the speed. So that's how much the goal is updating on each frame. And this using this to determine how much the rotation is happening. Okay, that is basically the behavior of the goal. So let's save this. And let's see if this works. So we can play. Okay. This looks good, but we cannot really see if it refreshes the. So let's just add a simple canvas. So what I'm going to do is I'm going to save this scene as goal test scene. So this scene is just testing the goal. And I'm gonna add a UI with a button just for testing. So it doesn't have to be a fancy button. We are going to just drag this, make this bigger so we can see it there. And just center it, something like that. And change the text to reset. And add the behavior of the goal and use, not the goal, so the robot has the richer goal test script. We can use the set and reset parameters because it was a public method. That's why we can do this. All right. So let's go back and have a look, play. Okay. So now we can see that this started from 1.2 height and it adds or minuses 1 meter in a random range. And the speed changes, the frequency of going up and down changes. So this is a good start for us to train our robot, I hope. Okay. Cool. I think this is good enough for us to train it. Of course, you can keep on improving the goal behavior to give a more difficult task for this robot. But yeah, let's begin set up our ML agent for the robot.